Okay, so here we're going to look at the graphs of the sine and cosine function. And we're going to begin by the idea of a periodic function. If y equals f of x is a function and a is a non-zero constant such that f of x equals f of x plus a for every x in the domain of f, then f is a periodic function. The smallest such positive constant a is the period of f. So let's look at the sine function. So the sine function looks like a wave. And so we often call it a sine wave or sinusoidal wave or sinusoid. The thing is the way I draw these is not really to scale always. So I just draw a wave really, but I can try to do better. So here I'm drawing this wave and I'm going to go to the left and the right, but in fact it keeps going forever and it should have better symmetry. But okay, so if I start at 0, I can go to 2 pi and then it repeats itself again. That's why I'm only drawing this part, but just to show that we can go the other way too. And I think that there's a lot of times when people explain these things, they go over back to the unit circle, and I just sort of avoid that. But it's true that if you think of the unit circle, what happens is that the unit circle repeats itself once you go around, which is 2 pi. So it repeats itself. And the maximum the sine can be is 1, and the minimum is -1. And then a lot of understanding these graphs or working with these graphs has to do with fractions. So half of 2 pi is pi, half of that is pi over 2. And so I call this the, all right, so anyway, I was going to tell you, I'm going to wait till I talk about this number, but if I take pi over 2 and I add that, I get pi. So pi over 2, I mean, if I take this pi over 2, from 0 to pi over 2, and then I add that again, I get pi, and I add that again, and I get 3/2 pi. These 0, pi over 2, pi, 3/2 pi, and 2 pi are called key points. I mean, the thing is that it's not as if universally everybody knows that. There could be, I mean, I think a lot of people who are mathematicians would not know that word key points. It's just, some textbooks call it that. So it's not like a universal word that we all should know. I mean, some of these are, but that one's just sort of one that the textbook uses, or maybe I use. All right, the period of y equals sine x is p equals 2 pi. This is a word that everybody knows around the world. That's the period. And what that means is that that's the shortest distance for which that interval, for which it then repeats itself again. I did a long explanation up above, but that's essentially it. It's the period. Okay, so let's go over some ideas that we should always talk about. Well, we don't all, but we might think about when we think of functions. The domain is all real numbers. The range is y is between -1 and 1. So the maximum that sine can ever be is 1, the minimum is -1. The period is p equals 2 pi. Now I have this idea of a quarter period, and I'm sure that someone else would say, well, what's a quarter period? They could just sort of figure it out by the name. So I just divide by 4. It's a useful number because what I do is to sketch the graph I want to label, and so I label the key points by starting at 0 and add the quarter period. Pi over 2 plus pi over 2 plus pi over 2 and pi over 2, because I want to label those key points. And why would they be called key points? Because those are x-intercepts, 0, pi, and 2 pi are x-intercepts. And then at pi over 2 we have a maximum, 3/2 pi a minimum. And then there's this idea, this word called a fundamental cycle. And that's between 0 and 2 pi. There's also something that we are interested in, which is symmetry. So does the graph have symmetry? I mean, by the way, I mean, these things that I'm writing down can be, you can know these just by looking at the graph. So is there symmetry? And the answer is yes. It's not quite that obvious to see. The graph of y equals sine x is symmetric about the origin. I'm not saying, I think we can see symmetry, but it's not really that clear how you describe it, I would guess. Like, how do you describe it? We see there's something going on there. So how do we describe that symmetry? And it's symmetric around the origin. And what that means is I'm going to just draw a little sine graph over here. Actually, up here I didn't write x and y. Okay, it means if you take a point and you go through the origin and you end up on the other side, you'll have a point it's an equal distance from the origin. So we pass through the origin. And so because of that, we could, by the way, this follows from the fact that y equals sine x is an odd function. I don't even know if I say it follows. It goes hand in hand. I mean, one implies the other. So f of negative x equals sine of negative x equals negative sine x equals negative f of x. So sine is an odd function, and a lot of times the way I explain it or remember it is by the symmetry through the origin. Odd functions are symmetric through the origin, and odd means that f of negative x is negative f of x.